Physics and chemistry are usually considered distinct and separate disciplines, but Giacinto Scoles and Peter Toennies have transcended the barriers between these two fields. In the process, they revolutionized the study of complex molecules and quantum physics. In our daily lives, we know that matter comes in three states: gas, liquid, and solid. But in the laboratory, liquid helium can form a fourth, very different superfluid state at very low temperatures. Peter Toennies and Giacinto Scoles have spent many years in friendly competition to find new and innovative uses for this extraordinary superfluid liquid.
Toennies and myself had for many years parallel careers. We've been playing ping pong with science together for many years.
In his laboratory at Princeton, Scoles was focused on using beams of light to study the properties of atoms and molecules, and developed a brilliant new technique called optothermal spectroscopy. But for his method to work, he needed to find a way to cool his experiments down to temperatures near absolute zero.
You cannot work at room temperature. You have to work at lower temperatures.
Thousands of miles away, Toennies and his group at the Max Planck Institute in Germany were shooting streams of helium atoms into a vacuum chamber. Cooled down to nearly absolute zero, the atoms bunched together to form tiny nanodroplets of superfluid helium. But the results weren't quite what they expected.
We found out that these droplets had the tendency to pick up some other atoms in the residual gas in the apparatus, and they contaminated our experiments.
But both Toennies and Scoles realized that what appeared to be a setback actually presented a novel opportunity. The ultra-cold droplets of superfluid helium provided the perfect environment for spectroscopy experiments.
We saw this effect that these spectral lines are so sharp, and that's exceptional among all the substances that we know.
Scoles and his Princeton colleague Kevin Lehman extended the technique to perform unusual chemistry experiments. The helium droplets can be used as tiny self-contained laboratories where every step of complex chemical reactions can be controlled and studied.
These helium droplets are basically an environment where we can synthesize new molecules or making objects, molecular objects, which have never been done before.
And while studying molecules trapped inside these droplets, Toennies and his colleague, Andrei Vilasov, made another astonishing observation.
These molecules were able to spin around their own axis, even though they were in a liquid, and all our previous experience had told us that in a liquid a molecule can't rotate.
If they rotate freely, you can measure the structure of the molecule. So it uses a structural tool to get information how the molecule has been made, especially if it's a new molecule, you need to know.
Both Scoles and Toennies saw these unique properties of the helium droplets as an unprecedented opportunity for scientific discovery.
It's the hope of physical chemistry and chemical physics to understand these interactions in great detail, because they will then give us the information needed to understand the way matter is assembled.
But how did these two scientists cross so seamlessly from chemistry to physics and back? Both of them attribute part of their flexibility to the opportunities they were given to live, study, and work internationally. Scoles went from Italy to Spain, Canada, and the United States. Toennies was born in Philadelphia and then crisscrossed between Germany and the US for work and study. Today, their techniques are used in over 24 laboratories around the world, and they hope that their pioneering efforts will lead to exciting new opportunities for discovery in biology and medicine, as well as in physics and chemistry.
We knew it was something new and interesting, but how important it's going to be, you can only know it after a few years later, how many people has followed you.
Meanwhile, Toennies and Scoles are continuing on with their own experiments, as well as their remarkable relationship.
And I'm very happy that we have this opportunity to share this award, because I think this will sort of cement our relationship of being friends and competitors at the same time.
The 2006 Benjamin Franklin Medal in Physics is awarded to Giacinto Scoles and J. Peter Toennies for the development of new techniques for studying molecules, including unstable species that could not be examined otherwise, by embedding them in extremely small and ultra-cold droplets of helium. Their work also led to a better understanding of the extraordinary properties of superfluid helium, such as its ability to flow without friction.